Hello everyone, I'm Projects, physics lecturer from Rwanda Polytechnic. Today's lecture is kinetics. We are going to have two parts. The part one is about Newton's laws of motion and their applications. The part two will be the examples of centripetal forces. So, kinetics is defined as the branch of dynamics that is concerned with the relationship between motion and its causes, specifically forces. You can ask yourself, what makes bodies to change their state of rest or uniform rectilinear motion? To answer this question, Newton did different observations and experimentations, and he observed that forces are agents that control the motion of objects. Then he developed three important laws which deal with force and mass. Newton's first law of motion, he called it Principle of Inertia. So, to understand the meaning of this law, you have to know what is inertia of a body. Inertia of a body is the tendency of an object to resist at any change of state of rest or motion. So, from observations and experimentations done by Newton, he saw that the greater the mass of an object, the greater the tendency to resist at any change of state of motion or rest. So, he defined the mass as the quantitative measure of inertia, because it helps to measure or to know the inertia of a given body. The statements of this law, the first law of Newton states that a body continues to be in its state of rest or of uniform rectilinear motion unless acted upon by an unbalanced external force. So, when the net force is equal to 0, the object cannot change the state. It will change the state of rest or uniform rectilinear motion unless when the net force is different to 0.
Newton's first law of motion. In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked on the ground would keep moving forever, or after some time would naturally stop moving? The ball will continue to move unless an object of force stops it. Here comes Newton's first law, which states a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. To understand Newton's first law, you need to understand what unbalanced force is. If you have seen a game of tug of war, you would have seen two teams pulling a rope in opposite directions. If the rope doesn't move, the forces applied by the teams are balanced forces as they are of equal magnitude in opposite direction. If one of the team applies greater force, it pulls the other team and the rope towards their side. In this case, the forces are unbalanced as the two forces are of unequal magnitudes in the opposite directions. If one of the team lets go of the rope, the opposite team falls backwards. This tendency to fall backwards despite letting go of the rope is due to inertia. That is, if an object is at rest, it tends to remain at rest, and if it is in motion, it tends to stay in motion. This property of an object is called its inertia. Inertia can be classified into three categories: inertia of rest, inertia of direction, inertia of motion. Certain experiences that we have while traveling in a bus can be explained on the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is the tendency of a body to resist any change in its state of rest. What happens when a fast-moving bus negotiates a right-hand curve on the road? The passengers will tilt to the left. Inertia of direction is the tendency of a body to oppose any change in the direction of its motion. With the application of sharp brakes, the bus stops all of a sudden and the passengers tend to fall forward. This is due to inertia of motion experienced by the upper part of the body. When the bus is moving, the whole body of the passenger is in a state of motion. A sudden halt caused by the lower part of the passenger's body that is in contact with the bus comes to rest. However, the upper portion of the body remains in the state of motion due to the inertia of motion, causing the passenger to fall forward when the bus stops suddenly. Inertia of motion is the tendency of a body to resist a change in its state of uniform motion. Thus, Newton's first law is also called the law of inertia. Well, now this law should make sense. Do you understand why a ball on the ground after being kicked does not keep moving forever? The ball stops after some time due to the unbalanced external force applied by the ground in the opposite direction.
Newton's second law of motion. It is called fundamental principle of dynamics. It is called fundamental principle or basic principle because it is the one used to solve problems of dynamics. So if you remember from the first law of Newton, a body can't by itself modify its state of rest or uniform rectilinear motion. So to stop or to push a heavy object, it requires a big effort than a light object. So as conclusion, the heavier object is said to possess a greater momentum than the lighter object. That is from observations of Newton from different experiments. So the momentum is defined as the product of the mass with the velocity. The second law of Newton states that the rate of change of momentum of a body is directly proportional to the net force on that body in the direction of the force. Proof of this statement: the applied force or the net force is proportional to the change of momentum divided by a change of time. That is what we call rate of change of momentum. Or the momentum is equal to mass times velocity. Then the force will be proportional to the final momentum minus initial momentum. That is the change of momentum, final minus initial, divided by the change of time. Mass is a common factor. then the force is proportional to the mass times final velocity minus initial velocity divided by change of time. If you remember, the difference of velocity, the change of velocity over the change of time, it is the definition of acceleration. This is the definition of acceleration. Finally, the force is equal to the coefficient of proportionality k times mass times acceleration. K is the coefficient of proportionality because the force is directly proportional to the acceleration, and the coefficient of proportionality between them is K. K is defined as the force divided by mass times acceleration. That is equal to 1. Thus, the force will be equal to mass times acceleration because K is equal to 1. Hence, the net force produces an acceleration in the direction of the force that is directly proportional to the force and inversely proportional to the mass. From this formula, force F, is directly proportional to the acceleration. And this acceleration is produced by the force. And acceleration is equal to force divided by mass. That is, the acceleration is inversely proportional to the mass. We have this. Acceleration is inversely proportional to the mass. The third law of Newton is called action and reaction, and it is stated as, for every action, there is an equal and opposite reaction. Examples: for a person who is swimming, here we have the action, the feet on the wall, it is action, and the wall will react to the feet and give the motion to the person, the forward motion. Here we have a free body diagram where we have the force wall that the wall exert on the feet is the one which will move the person, and it is equal to the force that the feet exert on the wall. That is action and reaction. And also, for the person who is moving, the person or the runner is pushed back and down on the ground. We have this force. And also the ground will react with the same force, but opposite.
Yes! Oh.
Hey!